We're going to do 19. I wanted to review with you the 4 steps, though. So you have to know how to do everything from a week ago. So you have to be able to find the x and y intercepts, and you have to be able to find the vertical and horizontal slant asymptotes. So I'm just going to write it up here as we kind of review it. You should already know these anyway. You don't have to write this down, but just for the people that are going to watch the video, how do I find a y-intercept? What do I have to do? Yep, plug in 0 for x. So you're going to do that first and find your y-intercept. Step 2, you're going to find your x-intercept, which is done how? Yep, so you're going to plug in 0 for y. Does anyone remember the shortcut for rational functions? Because you multiply the denominator to the other side, which then becomes 0 on the left-hand side. So you're really going to set your numerator equal to 0 and solve for x. So our second step is we want to set the numerator equal to 0, which leads into our third step, our vertical asymptote, because then we're going to set our denominator equal to 0 and solve for x. So if you kind of do it in the same order every time, first you plug in 0 for x, then you check out your numerator, then you check out your denominator, and then step 4, for your horizontal or slant asymptote, you're going to compare now your numerator versus your denominator, the powers. Right? So this last rule is kind of a 3-part rule because 3 things could happen. And these are already on your 18 notes. So this is just kind of like, hey, let's have this kind of to the side in our brains. But the first thing that could happen is the numerator has a bigger power. Right? Like x cubed is on top and just x is on the bottom or something. So you're going to do division to find your slant asymptote. So if it's whatever it is. So we practiced a little bit of that box method, but I think we need more practice on division. Number 2, they could be equal in power. So like, let's put an example. If this was x squared minus 2x plus 9 over x plus 3, right? The numerator just 1, we would do division. But if they were equal in power, 2x squared plus x over 3x squared minus 9, you strip the coefficients of x. So y would equal 2/3, so it's a horizontal asymptote. You strip those coefficients. And the last thing that could happen is that the denominator is the bigger one, like x plus 9 over 3x squared. If the denominator wins, it blows up, because this would be like a small number divided by a really big number, like a million. So y would just equal 0. So you're either going to do division to find your slant asymptote, strip the coefficients in front of those biggest powers, or the denominator blows up and you have a horizontal asymptote at 0. So to me, this is what makes rational functions challenging, this 4-step kind of rule. But if you do it in the same order each time, hopefully you'll be able to kind of memorize that, is my hope. So now we're jumping in to kind of step number 5. That doesn't happen all the time, but there sometimes are holes in rational functions, and all a hole is this darn wire. So all a hole is, here's your normal rational function, whatever it was. There's an undefined value on that graph, so it's just called a hole. So it's a place where the function is undefined, and it happens when we have a common term in the numerator and denominator. So it says if the numerator and denominator have a 0 in common, there will be a hole in the function's graph. To graph the function, you want to factor the numerator and denominator to discover any common factors, and you find the hole by evaluating the new function created by canceling the common factors at the undefined value. So I'll show you what that means, because that's a mouthful. But here is, I'm actually going to skip over to number 2 first, because it's already in factored form. So that makes it a little bit easier. Can you see that there's a common factor in number 2? So what would cancel? The x minus 2 here with the x minus 2 here cancels. Anything divided by itself is 1. So my new function, I'm going to leave it in factored form. I think factored form is always best. This is the function I want to answer those 4 questions about. I want to find the y-intercept, the x-intercept, the vertical asymptote, and then horizontal or slant. And then I'm going to go back to this at the very, very end and remember that I have a hole to deal with. So from this step on, it's exactly what you did on Thursday. So let's go through those steps. What's my y-intercept first? If I plug in 0, what am I going to get? Negative 15 in the numerator, right? Because I'd have negative 5 times 3 over 1 in the denominator, right? So my y-intercept would be at 0, negative 15, which is hard to plot. It's just somewhere down here. I'm just going to put it kind of way down below so I know there's a y-intercept somewhere down here. Now I'm going to do my x-intercept. So remember, for the x-intercept, your shortcut is you just look at the numerator. What would make that 0? 5, right? So 5 comma 0 is my x-intercept. 1, 2, 3, 4, 5. I can kind of see this is an elbow kind of bending this way. Now I look at just the denominator. What would make that be 0 and undefined? Negative 1. So x equals negative 1 is a vertical asymptote on my graph. And see, there's that elbow I was talking about bending towards that asymptote. And so we've done the numerator by itself. We've done the denominator by itself. Now we're going to compare the powers. They both have a degree of what? First degree, right? Linear functions. So if the degree is the same, you're going to strip the coefficients that are in front of those x's. So this is 3x over 1x. So 3 over 1 is 3. So y equals 3 is your horizontal asymptote. So that's the framework right there for that section of the graph. And I can assume that my elbow is probably up here in the top left because there's no other x-intercept. But to figure out a point that lies there, what would be a good x value to plug into my function? I want to figure out a value up here in the top left. What could I plug in for x? What? Negative 2 would be a good value because this is negative 1, the asymptote. So if I go over here to negative 2, what would I get? I would get 3 times negative 7. So that's negative 4, wait, 3, negative 21, right? Over negative 1. So positive 21. Does that sound right? Negative 2, positive 21 is way up here. So this elbow is really steep up in that top left quadrant because when I plugged in negative 2, I got positive 21. My last step is to remember, hey, I canceled something over here, which created a hole. This function doesn't show any problem at positive 2, but this function had a problem at positive 2 because in the denominator, 2 minus 2 would have given me 0. So I need to figure out where the hole is. The hole is at positive 2 because 2 minus 2 gave me 0. So I'm going to take 2 and plug it into my new function over here. So I would have had 3 times negative 3 divided by 3, right? Plugging in positive 2. What is 3 times negative 3 divided by 3? Negative 3, right? So do I go through that point? At 2, oops, I should have gone through negative 3. So just kind of adjust your graph to show that that's the hole. Pencil might have been better, but just kind of adjust your elbow. It should go through the point 2 comma negative 3, and that is my hole in the graph. That's how I showed that there was a hole there. So that's it. This is all the old stuff, the y-intercept, all that stuff, and then the new stuff is just that now there could be a hole. So I want to do kind of this front page, and then we'll take a break and go for a walk. So let's see. we have to be able to factor, right? Because this is now in standard form. So to get it to this point, we need our rules about polynomials to be able to factor this. So what are the factors of -2 that will add up to -1? X minus 2, x plus 1. And in the denominator, it looks like I've got a greatest common factor of x that I can pull out, x times x minus 2. Just a coincidence, but now my x minus 2's cancel again, just kind of like they did over here. It's not going to be the same factor every time, but x plus 1 divided by x is the function I want to work on. I don't want to think about this old function. I'm going to answer all my questions about this function right here. So I'm going to go through those steps again. So my first step is to find the y-intercept. What happens when I plug in 0 for x? Yeah, so there's no y-intercept. That's okay. There might be no y-intercept. All right, now I need to look at just the numerator. What will make the numerator equal 0? Greer, do you have these notes? You don't? Oh, so what's my x-intercept? -1 gives me 0 in the numerator, so it gives me 0 overall. So I'm going to plot -1 on the x-axis. All right, now I'm going to look at just the denominator. What will make the denominator equal to 0? For 0. So x equals 0 is my vertical asymptote. Kind of hard to show, but it's down the y-axis, kind of a dotted line. All right, that's my vertical asymptote. Now I compete numerator against the denominator. Where's the degree bigger, or are they the same? They're both a degree of 1. X to the first, x to the first. The coefficients are 1 over 1, and I strip those coefficients, so my horizontal asymptote is at y equals 1. So that is this horizontal line. So I can see that this has an elbow kind of going in this direction because the graph is going to hug those asymptotes. And more than likely, the other elbow is up here in the top right because there was not another x-intercept. So maybe I could just plug in a value of 1 into this function to see a point on that graph. So 1 plus 1 is 2 divided by 1, right? 2 divided by 1 is 2. So the point 1, 2 lies on this elbow of the graph. Now I just need to add my hole on there somewhere. And just like we did over here, this was undefined at +2. This is also originally undefined at +2, then we got rid of it. So I need to know where +2 is on this function. So my hole is going to be at 2, something. So I plug 2 into this function up top. So 2 plus 1 is 3 divided by 2, 3/2. So 1.5 is my hole. So that's about where I am, right? 2, 1.5 is about right there. So just show that there is a hole on the graph. Your graph should go through the hole. If not, you made a mistake. So on your test, you'd have to identify, like, I'm going to give you part A, part B, part C, part D, part E, hole. There might be no hole, and then you're going to have to graph it. And there'll be a couple questions you can use a calculator on to get those values. Okay, so I'd like us to do 3 and 4. Do you want to do one more together, or do you want to, yes, one more together, and then maybe you can try number 4? Okay, number 3. Here's a hint. If you don't like using the box method, rational functions can sometimes give you a hint about how the denominator might factor, because 2x minus 1 is a factor up here. So let's see if 2x minus 1 is actually a factor in the denominator, and that would save you a little bit of work if you're struggling with factoring. Maybe it's a factor, maybe not. If 2x minus 1 is a factor, what would the other factor have to be? So 2x times x would give me 2x squared, right? And what about the last term? Negative 1 times what will give me positive 3? It would be negative 1 times negative 3. So then you just have to check, does your outer plus your inner add up to negative 7? That'd be negative 6x, negative 1x. It does add up to negative 7x. So see how sometimes with rational functions, you can cheat a little bit and be like, oh, is this a factor? Let's check. It might save you some time. So I can cancel those 2x minus 1s. Make sure that you rewrite your function that x minus 3 is sitting in the denominator. And when you divide something by itself, you get 1. So 1 over x minus 3. And this is actually a pretty easy rational function to graph. It has a y-intercept, an x-intercept, vertical asymptote, horizontal asymptote, whole. Kind of go in that same order every time. Does someone think they could give them all to me? What do you think? Y-intercept, plug in 0. What do you get? Negative 1/3, yeah, or 1 over negative 3. So that's right here. X-intercept, you just look at the numerator. Could the numerator ever equal 0? No, the numerator always equals 1. So there's actually no x-intercept. That's okay. There has to be an x value up here for there to be an x-intercept. Vertical asymptote is at? What will make the denominator fail? Positive 3. And where is the power of x the biggest? In the denominator. So if you plug in a really big value for x, 1 divided by a really big number approaches 0. So it has a horizontal asymptote at y equals 0. So I can see that this elbow must just kind of cut through and then bend down. And I'm not sure. This could be up top or it could be down in the bottom because there's no x-intercepts. So I could plug in 4, right? This is at 3. So I probably want to plug in 4 and see what I get. 1 divided by 1 is what I get because 4 minus 3 is 1. So if I plug in the value 4, I get 1 as my output. So 4 comma 1 is there. So there's my other elbow. My last step is the whole. So the whole, I look back up here, where was this originally undefined that canceled that out? Where would 2x minus 1 equal 0? And it would be at positive 1 divided by 2, right? Positive 1/2. So my whole is at 1/2. I need to plug 1/2 into this. So that's going to be some fraction, right? Because you've got 1 divided by parentheses 1/2 minus 3, negative 0.4. Is that about where my graph is? Yeah, right? Negative 0.4 is about, well, let's see. I'm at 1/2 and negative 0.4. I'm like kind of like right there. Kind of hard to draw where that hole is, but I'm at positive 1/2 on the x-axis and negative 0.4 on the y-axis. So I took the value 1/2 and I plugged it into this function. So there's my 1 divided by parentheses 1/2 minus 3 on my calculator. If I gave it to you without a calculator, I would try to make it come out to a nice value for the whole. To me, that would be a calculation. All right, you're going to take a couple minutes and try example 4. Kind of do those 4 or 5 steps. See if you can get there. I don't think it's any harder than the other ones. Here's a hint. When you get to the denominator, do the greatest common factor first, because it'll make it a lot easier for you to factor the rest of the way. So start out by factoring out a 3. then this trinomial will factor much easier. You don't have to use the box method for that one. And same thing in the numerator. Start by taking out a 5, then you have x squared minus 4 left, so then you can do difference of squares. Right? If you take out the greatest common factor, it'll help you factor that the rest of the way. I got it. So here's the function that I'm looking at, the 5 times x minus 2 over 3 times x plus 2. So my y-intercept is at negative 5/3 because when I plug in 0, I get 5 times negative 2 is negative 10, 3 times 2 is 6. So negative 10/6 is negative 5/3, so negative 1 2/3. There's my y-intercept. So dealing with fractions, that might be tricky. So then the numerator is 0 when x is positive 2. So that is a x-intercept at positive 2. The denominator is 0 at negative 2, so the negative 2 is the vertical asymptote. And the powers are both linear, degree is 1. So when you strip the coefficients, you get 5x over 3x, so 5/3, or 1 2/3 is the horizontal asymptote. So kind of all 4 of those pieces have to fit together correctly so that you can see the elbows of your graph. I plugged in the value negative 3, I think. I plugged in negative 3 to get that value. It was like 8 1/3. Negative 25 over negative 3 is like 8 1/3. And there's no hole. The reason there's no hole is, where do you want to put the hole? Negative 2, right? Well, because the two factors in the denominator were both x plus 2, x plus 2, it was nice that it canceled out, but a vertical asymptote is still there at negative 2. So you're not going to put a hole on top of an asymptote. The asymptote is already undefined. So you don't need the additional hole. Where would you put it, right? It's just undefined on that whole space. So now we're going to do 1 through 4 on the next page. Thank you.